So this kind of problem is stuff that you'll see in calculus when you're applying the quotient rule. Not that you have to worry about that now. Now, a different approach to this would be to realize that, gee, that negative number, that negative term, means that goes in the denominator. Not into this denominator, but into the denominator of the x. So let me write it as this: 4 times 7 plus x to the 1/2 over 1 minus x over 7 plus x to the 1/2 over 7 plus x. So all I did was I just put that into the denominator with the x. How come x stays up in the numerator? Even though it's not written, it's understood to have a positive exponent. This becomes a complex fraction. And our idea, our trick in working with complex fractions was to multiply by the lowest common denominator of these fractions right here. So in this case, the lowest common denominator is just going to be 7 plus x to the 1/2. So I'm going to multiply by 7 plus x to the 1/2 here. And I also have to do that in the denominator, 7 plus x to the 1/2. Now, that term has to multiply both of these in the numerator. It has to distribute itself here and here. Let's start with the top part, or the second of these. When I distribute this to here, can you see what's going to happen? That's just going to cancel out altogether, right? All right, so that's kind of nice. That leaves me with just an x here. And how about this times this? Well, when you multiply things with the same base, like a to the 3rd times a to the 4th, you don't get a to the 28th, you get a to the 7th, right? Because you add the exponents. Same thing's going to happen here. If you add the exponents, what's 1/2 plus 1/2? 1. So I get 4 times 7 plus x to the 1st power minus this. In the denominator, again, play that game of adding exponents. This times this, oh, well, add the exponents. 7 plus x, 1 plus 1/2, or 1 plus 1/2 is 1/2, or better yet, 3/2. So there's the 3/2. Do I really need the 1 here? No. So I can just distribute this right away. It's just to the 1st power. 4 times 7 is 28. Plus 4x minus x over 7 plus x to the 3/2 power. These combine to give me 28 plus 3x over 7 plus x to the 3/2. So perhaps a more efficient way to solve this one. Yeah?
Can you explain the 3/2 again in the denominator?
Sure. It's not really written as 7 plus x to the 1st power, but you can write it that way. And putting it in parentheses like this, then these things have the same base. Now the idea is when you have things that have the same base, you keep the base and just add the exponents. 3 plus 4, 7. In this case, 7 plus x is our base. And if I add the exponents, I get 1 plus 1/2. That's 1/2, or converting that to an improper fraction, 1 times 2 plus 1 is 3. 3/2 is my exponent. So let me check the chat here. Is there a follow-up question? Oh, no. I was muted. All right, so I think, sorry about that. I imagine that means my video is ruined too, but whatever. Maybe I can make another one. All right. So kind of a quick recap for those of you who didn't quite catch the audio. I wrote this in the denominator. And because it's a secondary fraction, to clear out the secondary fractions, I've multiplied by 7 plus x to the 1/2 power in both numerator and denominator. When this distributes itself here, it cancels. It leaves me with the x. When this multiplies this, you add the bases, or add the exponents, because when you're multiplying with the same base, you add the exponents. So 1/2 plus 1/2 gives me 7 plus x to the first power. And then, of course, divided by 1 we can ignore. Distribute the 4, combine like terms. In the denominator, these exponents add. 1 plus 1/2 gives me 1.5. And then combine like terms in the numerator. Awesome. Awesome.